again, I'll collect this or check this off tomorrow. So those who weren't here. So it was 4.1. It was scatter plots. Yes. All right. So first problem that's in there. Your x value is price. Your y value is sales. Okay. If you plug these into your calculator, your explanatory variable is your x value, and y is your dependent variable. Okay? So, this was basically what we had gone over last time. And so with that known, with this, we can answer the rest of our questions from 4.1. So, height versus free throw. Height is x, free throw is y. And let's plug this into the calculator to have some fun. Oh, by the way, I will not be in my office today. I have, after this class, go to Grandview, then to Cherokee Trail, then to Overland. So I will be back here at 3 o'clock for a meeting with some people in my department, but I won't be here. But tomorrow, I'm pretty much open. Monday, I have a meeting at 10 o'clock here in the school. And then after that, I will be free to chill. Okay? Hey!
Hi.
How you doing, Cupcake? Good. No, very little. Let's see. Henry is here, and Evan is not, and Caesar is not. Okay. Henry, that's for you. All right, I want to plug this data in. So I said height was x, free throw percent was y. I'm going to go into my calculator. I'm going to hit stat, edit. That big old screen I got up there for y'all. All right, so cool. So I'll clear that out, go over here, clear out that data. L1 usually will represent x, L2 will represent y. So I'm going to plot my data. I have 80, 77, 83, 71, 69, 75, 80, 79, 82. So with 80, we have 68. 70. I'm getting all kinds of dumb moods. 70. 83, we have 58. 71, we have 76. 69 is 75. 75, we have 91. What'd I do? 70. 79 and 64. Winston's hacking into 9 News right now, getting them to run the screen that school's closed. It'd be awesome. All right. You open the gates both ways on the tollway on 25. All right. That's our data plugged in there. If I hit y equals, make sure I don't have anything in there. Clear that out. And then go ahead and hit zoom and stat. So zoom 9. So if we look at our data, if I were to draw a straight line, would you think straight line would follow that arrow that way? Or do you think straight line would follow it up to the right? So would it rise up to the right, or would it drop to the right? Drop. So if I were to find the slope of this line, would it have a positive or a negative slope to it, would you think? Negative. So now we want to find the line of best fit. So a line of best fit, if you remember from the old days in science, you kind of took a ruler, you tried to estimate the best way it would fit, then you picked 2 points that you could find the slope from, and from the slope you then can use the point slope, and from the point slope, what'd you hack into? You changed his grades to all A's. Ferris Bueller, what's up?
How did you do that? What?
Keep going.
Change my grades.
No.
You got a full ride scholarship at MIT? Holy cow.
Sorry, Mr. Sherman.
No, my gosh, you're fine. All right, so let's find the line of best fit. So I'm going to go back to stat. I'm going to go to calculate. I'm going to go down to linear regression. Now, a couple things I want you to see. Let's make sure this happens. I have linear regression as number 4, and then there's another linear regression as number 8. Okay? They're going to find the same thing. So number 4 and number 8, just notice I have ax plus b and a plus bx. This is calling a the slope. This is calling b the slope. It's going to be the same stuff for you, but we'll always just use the first one. So I'm going to find the linear regression for list 1, comma, list 2. Some of you might already tell you list 1, list 2. Hit enter, and that's some information. So our linear regression to this problem is we have y equals negative 1.215x plus 1.64964. And then we have r squared and we have r. Now remember, those are the diagnostics to this. R stands for how well our data is going to fit. The a, which is the slope of our line, and the r need to be the same sign. So they both have to be negative. So this is going to work out. So it says, use your calculator, make a scatter plot, make a simple sketch. Okay, we got it. Do the data show positive or negative association? It's a negative slope. R is negative, so it's a negative association. Something went wrong if R is positive and your slope is negative. It shouldn't happen that way. So something moved up on your calculator. Does the data look like linear or nonlinear relationship? It does look linear. And then does the linear relationship look strong, moderate, or weak? So this is what you're going to look at when you want to know if your information's good. You're looking at your R squared value. We feel that with our data, we're 40% sure. So our variance is 40%. We're 40% sure that is the correct line of best fit. Now, statistically, if you came up with something like this, things that you should do if you felt it was a linear relationship is collect more data. Make sure your phones are away, please. So if you collect more data, the variance is going to lower down, becoming closer to 1 or closer to negative, or closer to 1, which means the closer we are to 100%, the better our data. So does this have good variance? It's 40% sure that's the right line of best fit. Okay, yeah.
This is 4% in this case.
In this case.
Right. What is, like, like in physics, a certain, like, you're going to go to term, you can't get, like, perfect, friction, whatever the number is.
Usually above 80% is pretty good. Yeah, but it depends upon which industry, too.
Okay.
Like, do you want 80% in airlines? That means that they're 80% sure that's the right metal. Get something screaming across the air at 500 miles an hour. I want that closer to 1. In medicine, is it good enough? Well, it depends. You have a terminally ill situation. If we do this, we have a 40% chance that it's going to work for you.
So it fluctuates based on the industry.
Could, yes. What's the scenario? Are we 40% sure that the orange is going to be nice and sweet and juicy? Okay. Bad orange might not be a horrible thing. You throw it away. So I'd say, base your situation on what you're going to do with it. Do you want to put a pharmaceutical drug out on the market for a certain condition that only works 40% of the time? Probably not. Now, if it works 40% of the time, but there's no bad side effects, then it might be worth it. What conclusion do you draw about the relationship between the height and the free throw percentage? They're really not related to each other. Okay? If you added many more players to the scatter plot and recalculated, would you be more confident about the conclusion drawn here? Yes. Okay, again, if you add more data and your data falls more into that linear relationship, then I would say That's a good thing to do. Why should I not just use two pieces of data?
It's not accurate.
But it would be 100%.
Between two pieces of data.
Right. So the minimum amount of points you need for a line is two points. So if you move this down to two pieces of data and say, oh, look, I have 2 points. Your R value is 1.00. Your R squared is 1.00. Is that something acceptable? I mean, 2 pieces of data is really not enough. But in geometry, 2 points define a line. But it's not necessarily for the study. Okay. Identify each situation as to be positive or negative association. Class absences and grades. So the more absences are on the x-axis, and class grades on the y-axis. Now I realize there's that one kid that you might know that missed every day and still got an A in class, right? But most kids can't miss a tremendous amount of school if they're in the age-appropriate, class-appropriate type of situation. The more you miss of school, the lower your grade should be. Are there exceptions to the rules? Yes. What are exceptions to the rules called? Outliers. Okay, B, a scatter plot.
Is that positive?
Oh, so I'd say it would be a negative association. You're going to have a higher grade with the less absences. So, and as you had more grades or had more absences to the right, the lower your grade would get. So negative association. A scatter plot of points scored by football team and losses by the team. So the amount of scores, the points scored by a football team and the losses by the team. Let's think about that. Yes. All right. Points as it increases and losses. So would you think a team that scored a lot of points would have less losses if they didn't score as many points? And then you have the Broncos. Seem to score a lot of points, but they lose. So I'd say we have a negative association with that. Scatter plot of the price of lemonade and the amount of glasses of lemonade sold. Okay, this starts getting you into economics, and there's something called the supply and demand curve. So the price of lemonade and the number of glasses sold. So as the price of lemonade and the number of cups, low price, maybe lots of cups. High price, not so many. And a scatter plot of Cherry Creek High School students' ACT and SAT scores. This is a trick question. It doesn't matter which one's on the X or on the Y. The ACT does not influence your SAT, and your SAT does not influence your ACT. So I'd say a student that scores low on the ACT probably scores low on the SAT. A student that scores high on the ACT probably scores high on the SAT. So I'd say you definitely have a positive correlation there. Scatter plot of the month of the year a person was born and their SAT score. I'd say there's no correlation. So month and and your test, I bet you it's all over the place. There's no correlation to it. So that's what I got there. And then number 3, using the above scatter plots, which shows a positive between variables. D, which shows a negative association with variables. And I guess you could fight that on letter A, the first one. A and D both show positive. One's a little bit better than the other. Which shows negative? B is negative. Which shows no association? C, which represents the strongest linear relationship. I'd say B, it's a negative relationship, but the values are the tightest together. Which shows the weakest linear relationship between variables? I'd say C. You could probably get a line and it's not going to be exactly 0, but it could be close to 0. And which looks like it could be strong, but a linear curved relationship? Perhaps D. Looks like it could be a logarithmic relationship if you wanted to push the issue. So that's what I have on that. So I will mark that off for you guys tomorrow. Those who are sitting at home, hopefully they finish it up. Okay. So, you guys with me? All right. So 4.2, next page, explanatory variable. That's the x. So the explanatory variable, being the x, does not control the cause. The x should not influence the y. Okay? The response variable is the y. And the y is influenced by the explanatory variable. So the y is influenced by the x, but the x is not influenced by the y. If you were to figure out your r value should go between -1 and +1, where 0, the closer to 0 you are from either end is bad data. The closer to 1 or -1 is good data. -1 means it's going to be a negative sloped line. +1 is a positive sloped line. Go ahead. When you deal with r squared will be between 0 and 100%. Okay? R squared is between 0 and 100% because if we square a negative value, it's got to be positive. So if your r squared value is closer to 0, that means you have a lot more, has less variance than the 100%. You want it to have more variance to it. Okay? The least square regression line. So the least square regression line, you guys know this. They have it as y hat equals a plus bx, and we have to know that there's another equation in there that's ax plus b. These are both linear equations. Okay? Which one should we use on our calculator? Should we use number 4 or should we use number 8? At this point, it's not going to matter a whole lot for you. Okay? And then using the TI-84 or 83, this is going to work for you. If you use linear regression, if there's no outliers. If you have outliers, so if you had your data like this, and then you have like something down here and then something up here, and you have some outliers, so then you're going to use the median regression. That's going to be a little different. We'll talk about that a little bit later. Correlation versus causation. Correlation is positive or negative. Correlation does not mean one variable causes the other. It says X has very little influences in connection, but it does not cause the Y to happen. And then I am almost done. All right, example 1. The following equation is a regression equation for NBA three-point shots scored during the season versus the number of wins during the season, where X was the number of three-point shots made this season and Y is the number of games won. They tell you that once you plot your data, your R value is 0.87. Your R squared would be 0.87 times 0.87, which would be 0.7569 roughly, or 75.69. Okay, so the explanatory variable here is the X variable. They tell you what the X variable is. That's the three-point shots. B is, what is the response variable? That's the number of games won. And then the slope of this particular line, let's justify what the slope is. They tell us that our equation is this. What value is my slope up here? 0.21. So can I put this over 1? Because slope should be a fraction. Could I have changed this to 21 over 100? Okay. So either way is correct. So let's try and define this. So remember, slope is the y component over the x component. The y component is what in this case? It says x is the number of 3-point shots. Y is the number of games won. So y is games won over 3-point shots. So we could look at this a number of different ways. I'm going to take the 21 over 100. For every 21 games won, 100 3-point shots were made. Does that make sense? For every 21 games that we won, there was 100 3-point shots taken. What is implied about the y-intercept? What do you think? What can we imply from the y-intercept?
Positive correlation.
It's positive, but the y-intercept. So if we drew this line, we would cross on the y-intercept 4.38. So at 0, 4.38, we're across the y-axis. What can we say about it? What does y represent? Okay. What does x represent? So how would I have the point 0, 4.38? What has to happen? How do I get the point 0, 4.38? On algebra 1. 0 3-point shots. So if there are 0 3-point shots in a season, they look to win 4.38 games. That's all it means. Is the relationship positive or negative? It's positive. Our slope is positive. Is the relationship weak, moderate, or strong? They tell us we have an R value of 0.87, so that's pretty strong. Will the relationship make accurate predictions? Well, if we go 0.87 and we square it to get the R squared value, we get 0.7569, which is 75.69%. It's pretty strong. I mean, we're talking about basketball wins and 3-point shots. Is it okay to make a observed decision on this at a 75% rate? Say yes, John. Good. Yes, absolutely. All right. And then, let's see, number 2. I'm just going to go through it quickly. X is the days that we diet. Y is weight. The explanatory variable is the X variable, which is the days on the diet. The response variable is the Y component, which is the weight. And then if we graph it, that's easy to do on our scatter plot. And I think you would be able to satisfy that pretty easily. So what I will be marking off today, or tomorrow, I will mark off worksheet 4.1. And I will mark off worksheet 4.2. What I'll do is I'll have them under the same thing, so I'll put it in as 20 points. Sound like a deal? Not here today for any extra help or fixing and finishing tests. Tomorrow, I'm here for the most part the whole day. Monday, I have a 10 o'clock meeting here, but after that, I'm free. And then that's as far out as I can go on my schedule. Sound good?